Let's see how we are going to evaluate the limit of this multivariable function, and we have x, y approaching 0, 0. So first, if we plug in 0 and 0 into x and y, we get 0 over 0. We cannot draw any conclusion based on that. So maybe let's just start by plugging some path and see what happens. First, I'm just going to go along the x-axis. And when we go along the x-axis, that means y is exactly equal to 0. That means I can plug in 0 into the y and x will be approaching 0. So that's the limit, x approaching 0. And then we have 2x times y is 0. And then to the fourth power, x squared plus 0 to the 8. Okay, that's the limit as x approaching 0. The top is 0, the bottom is x squared. Then remember, we do this inside out. 0 divided by x squared is 0. So that's the limit, x approaching 0 of 0. So the answer for this is just equal to 0. Okay, maybe we can try along the y-axis. But that means x is equal to 0. Right away we see 0 over y to the 8th. That will give you 0 as well. We cannot draw a conclusion and say this is equal to 0 because in order for a limit to exist, it has to exist based on all possible paths. If you only have 2 that give you 0, it's not enough. It's actually easier to try to come up with a different path that gives you a different limit so that we can actually say this limit does not exist. So maybe that would be a better strategy. Okay, what do we do next though? How about let's try y is equal to x. So we're just going to the origin on the diagonal. Okay, let's go ahead and try it along the diagonal, y is equal to x. Let's see if it works or not. That will be the limit. I'm going to keep the x, and we will have 2x, y is now x. Okay, and then we can simplify this a little bit. The top is 2x to the 5th, and the bottom we can factor out x squared. 1 plus x to the 6th. And we can reduce this a little bit. That's going to be the third power. So it's the limit as x approaching 0 of 2x to a third power over 1 plus x to the 6th. Based on this, when x approaches 0, you put 0 into here, and here, you get 0 over 1. So, oh no, because we end up with 0 again. Again, that will be just another path that gives you 0. You cannot say the answer is indeed equal to 0. It's not enough. Okay, so maybe let's try another one. Here's a strategy on how you can do it. On the bottom here we have x squared, and then here is y to the 8th. So what we want to do is, you want to somehow make them the same, so that maybe you can combine terms and then you can cancel it. And in order for this and that be the same, x has to be y to the 4th power. And will that give you the origin? Yes, x and y will be both approaching 0. So let's try along. We want x to be y to the 4th power. So that means I'm going to keep the y now. I will put y to the 4th power into the x here. So this is the limit as y approaching 0. And then we have 2y to the 4th. And then another y to the 4th. And then y to the 4th to the 2nd. And then plus y to the 8th. Now work this out a little bit. On the top is 2y to the 8th power. You add the exponents. And this is y to the 8th. Plus y to the 8th, so we have 2y to the 8th. Haha, guess what? Y to the 8th cancel with y to the 8th, and you can see this is the limit of y approaching 0. 2 over 2 is just 1. When y is approaching 0 of 1, the answer is equal to 1. And yes, because finally we can see that the limits are not equal. So you can use this and that, and you can say the limits are not equal, right? You can also say this and that, yeah, whichever one. But you can never say this and that, the answer is 0. You can say this and that because not equal, and come here and say the limit does not exist. So the strategy is think about how you can pick the x so that you can combine terms and simplify it. It's usually not easy to come up with different paths that give you different limits. This kind of thing can be really tricky. I do have another video showing you guys some hard-to examples right here. Go ahead and check it out.